let's continue our discussion of inverse Z transforms. In class activity 3, use the power series method and the partial fraction expansion method to find the inverse Z transform for the system described by the following transfer function. F of Z is equal to Z minus 4 over Z squared minus 3Z plus 2. So the power series method first. So I'm going to have Z minus 4 divided by Z squared minus 3Z plus 2. So my first term will be Z to the negative 1, and when I multiply, I get Z minus 3 plus 2Z to the negative 1. Then I subtract, and I get negative 1 minus 2Z to the negative 1. The next term is negative Z to the negative 2, and when I multiply, I get negative 1 plus 3Z to the negative 1 minus 2Z to the negative 2. For the next term, I multiply by negative 5Z to the negative 3. And when I subtract here, this is negative 5Z to the negative 1 plus 2Z to the negative 2. And multiplying by negative 5Z to the negative 3, I get negative 5Z to the negative 1 plus 15Z to the negative 2 minus 10Z to the negative 3. So f of Z is equal to Z to the negative 1 minus Z to the negative 2 minus 5Z to the negative 3, and so on. F of N is equal to delta of N minus 1 minus delta of N minus 2 minus 5 delta of N minus 3 plus dot dot dot. So f of 0 is equal to 0. F of 1 is equal to 1. F of 2 is equal to negative 1. And f of 3 is equal to negative 5. So now we will examine two different ways to do the partial fraction expansion. The first method we're going to use involves multiplying by Z over Z. So we are going to have f of Z is equal to Z minus 4 over Z minus 2 times Z minus 1, and we're going to multiply that by Z over Z. So then what we would have is f of Z over Z is equal to A over Z plus B over Z minus 2 plus C over Z minus 1. So next we solve for A. A is equal to Z minus 4 over Z minus 2 times Z minus 1 evaluated at Z equals 0. A is negative 2. B is equal to Z minus 4 divided by Z times Z minus 1 evaluated at Z equal 2. B is equal to negative 1. And C is equal to Z minus 4 divided by Z times Z minus 2 evaluated at Z equal 1, which equals 3. F of Z over Z equals negative 2 over Z minus 1 over Z minus 2 plus 3 over Z minus 1. So f of Z is equal to negative 2 minus Z over Z minus 2 plus 3Z over Z minus 1. So then you go to the Z transform table, and we get that f of N is equal to negative 2 delta of N plus the quantity negative 1 times 2 to the N plus 3 U of N. To check our work, we would put in f of 0 and we get that f of 0 is equal to 0, which is the same as what we got before. Then we put in f of 1, and we get that f of 1 equals 1, which is the same as what we got before. F of 2 is equal to -1. That's the same as what we got before. And f of 3 is equal to -5, also the same as what we got before. So now let's look at an alternative method to do the partial fraction expansion. This method uses the property of delays, and we know that a delay in the z domain is a multiplication by z to the -1. So we would have z to the -1 times g of z, which equals z to the -1 times z times z minus 4 over z minus 2 times z minus 1. So then what we do is we find the partial fraction expansion for g of z, and then once we get the answer at the end, we delay it by 1 to be f of n. So g of z over z is equal to z minus 4 over z minus 2 times z minus 1, which equals a over z minus 2 plus b over z minus 1. So when we solve for a is equal to z minus 4 over z minus 1, evaluated at z equal 2. So a is equal to -2. B is equal to z minus 4 over z minus 2, evaluated at z equal 1. B is equal to 3. So g of z over z is equal to -2 over z minus 2 plus 3 over z minus 1. So g of z is equal to -2z over z minus 2 plus 3z over z minus 1. So then when we go to the z transform table, we get that g of n is equal to -2 times 2 to the n plus 3 times 1 to the n u of n, and f of n equals g of n delayed by 1. So f of n is equal to -2 times 2 to the n minus 1 plus 3 times 1 to the n minus 1, that entire quantity, times u of n minus 1. And now let's check our work. So f of 0 is equal to, so f of 0 is indeed equal to 0. F of 1 is equal to 1. F of 2 is equal to -1. And f of 3 is equal to 5. So this solution does check.